Okay, hi, this is Lees going through the 2016 SQA National 5 Mathematics Paper 1, and we're going to do question 7 to the end. There's question 7. You're given this pyramid that has got, it's a rectangular base pyramid, and you're given two coordinates in it. There, A is 2, 0, 0, and the point V is 5, 2, 6. Write down the coordinates of the point. B is the first one. Well, there's B. Okay, now the coordinates of a point is how you would get from the origin to it, basically. Okay, now we need to basically get this point here, and this is all important. V is the point 5, 2, 6. So you have to go 5 along, 2 back, and 6 up. Now, from 2 to 5 is a jump of 3. Adding on a further 3 makes that point there 8. From there to there is halfway from there to there. So from there to there has to be 4. And B is lying on the XY axis, so it has no Z coordinates. So B is the point 8, 4, 0. Okay, right. Part B. I'm going to do this in two different ways depending on how you may have approached it. Calculate the length of A to V in the pyramid. Okay, so they're wanting the length of this line here. Now what I'm going to do is I'm going to focus on this right angle triangle for the first method that I'm going to use. For this right angle triangle, I need to know the length of this line, and I need to know the length of this line. Now I know this one here, it's 6. It's 6 up from the XY axis. I need to get this. Now this line here, if I look at this here, now remember this is a right angle triangle. There it is there. Now from 2 to 8 is a jump of 6, and from 8 to B, that point there, to B is a jump of 4. So if I draw a triangle there, this is looking at the pyramid straight from the top. So there's 6 and there's 4, and as you can see, this is Pythagoras, okay? So we have AB squared is 6 squared plus 4 squared. So 6 squared is 36, 4 squared is 16. Now 36 and 16 is 52. Now AB is the square root of 52. Okay, now you might remember Surge from National 5 days. The root of 52 is root 4 times root 13. Okay, 4 13s give 52. The square root of 4 is 2. So the length from A to B is 2 root 13. Okay, now that means that from there to the point just below V would have to be just 1 root 13. Now, if I can now focus on this triangle here, A to the middle, up there, right. So from there to there is my root 13, and there's the height of it there. Now we're going to use Pythagoras again. So AV squared is root 13 squared, which of course is 13, plus 6 squared is 36. Okay, 13 add 36 is 49, and that would make AV to be 7. So that's a double use of Pythagoras. Now, the other way, and admittedly a quicker way, is to use the coordinates from A to V. Now, what's the vector that takes you from A to V? 2 to 5 is a jump of 3, 0 to 2 is a jump of 2, and 0 to 6 is a jump of 6. So the vector that will take you from A to B is 3, 2, and 6 on the Z. How do you get the length of a vector? You square each coordinate, add them, and then root them. So 3 squared is 9, 2 squared is 4, 6 squared is 36. So we've got root 49, which is 7. Okay, and on to question 8. We have to solve the equation 2x over 3, take 5/6 gives you 2x. Okay, so there we have it there written down. I'm going to get rid of the denominators there by multiplying everything by 6. Why? Because 6 goes into 6 and 3 goes into 6. Okay, it's and then what we do to this side, we have to do to this side here. So Taking it nice and easy, 6 times 2x over 3. 6 times 2x is 12x over 3. Take 6 times 5 sixths. 6 times 5 is 30 over 6. Taking my time here, equals 6 times 2x is 12x. Now 12 divided by 3 is 4. Take away 30 divided by 6 is 5. Okay, and then we have my 12x. 4x, take 12x, minus 5 over the side becomes 5. Don't forget, change the side, change the sign. 4 take 12 is minus 8, equals 5. So x is 5 over 8. And don't forget, it's negative 5 over minus 8. There we have it there. Question 9. A function f of x is defined as 2 over root x. Express f of 5 as a fraction with a rational denominator. That means we don't want a square root sign on the denominator. Okay, so f of x is 2 over root x. So f of 5 is 2 over root 5. And how do we get rid of that? Well, we multiply it by root 5 over root 5. Now, root 5 over root 5 is 1. So we're essentially multiplying it by 1. Okay, which won't make it bigger, won't make it smaller, but it will change the appearance. You multiply two fractions, you multiply the two numerators, 2 root 5, and root 5 times root 5 is 5. So there's your answer there. On to question 10. Okay. Sketch the graph of y equals x take 3 squared plus 1. Okay. On your sketch, show clearly the coordinates of the turning point and the point of intersection with the y-axis. So there's a couple of things I really want you to focus on. Okay. Now, crucial to this is you knowing that given a parabola in this format here, the turning point, the x-coordinate of the turning point is the opposite sign to this. So that's 3. And the y-coordinate is just that point there. So the turning point is 3, 1. Okay? So there we have it there. Now you can see me doing my not very impressive sketch here, but here we go. There's 3, and you can see that I've maybe scaled the y-axis 1 centimetre, standing for 2 units. Okay? And here we go here. Now when x is nothing, let's find out the y-intercept. Y is nothing take 3, which is negative 3 squared, and then add 1. Negative 3 squared is 9, add 1 is 10. So when x is nothing, y is 10, and that's why I scaled the y-axis the way I did. 2, 4, 6, 8, 10, nothing, 10, and there's my turning point there, 3 along. Done my best to get halfway up there, 3 along, 1 up. And just to strike a little bit of balance here, 0 to 3, if this goes through 3, 1, then that's a jump of 3. If you go another 3, you're at 6. 6, 10 will also be on the parabola. So it's just another point to help me draw it properly. Okay, this is lovely and symmetrical. There we have it there. Or at least that's the best I could do. There we go there. Question 11. Simplify tan squared x cos squared x. So, and you have to show your working, of course. Now, a couple of crucial things here. Sin x over cos x is tan x. That's a fact that you have to be aware of. Tan squared x means the tan of x squared. And this is the fact here. Tan of x is sin x over cos x squared. So that's sin x over cos x times sin x over cos x, which is sin squared x over cos squared x. So, going back to what I started off with, tan squared x, cos squared x, there we have it there. And these two things cancel out, and you're left with, to my view, not very satisfying sin squared x as a final answer. Okay, there's another sum. Here we go here. Question 12. The diagram below shows a rectangle and a triangle. All measurements are in centimetres. Part A says find an expression for the area of a rectangle, Well, the area of a rectangle from years ago is length times breadth. So here are your two dimensions, 2x plus 1 times x plus 8. Taking it nice and easy, 2x times x plus 8 plus 1. times x plus 8. So we have 2x squared plus 2x times 8 is 16x, plus 1 times x, and plus 1 times plus 8 is plus 8. Tidying it up a bit, we have 2x squared plus 17x plus 8. Part B. Given that the area of the rectangle is equal to the area of the triangle, we have to show that this is the case once you've done the maths. Okay, so let's turn our attention to the area of the triangle. There we have it there. Again, from a long time ago, the area of a triangle is a half times base times height. Okay, so it's a half times 2 times x plus 5 times the height is 3x. Now, a half times 2, times can be replaced with the word of if you want. A half of 2, which is just 1 times x plus 5, so that's just x plus 5 times 3x. Swap it around if you want to take your time. 3x squared plus 5x gives you 15x. So the area of the triangle in algebra is 3x squared plus 15x. Okay, so given that the area of the rectangle is the area of the triangle, then that must be the case if you're talking algebraically. I'm going to move everything over to this side here. So we have our 3x squared plus 15x, change the side, change the sign. So that'll be take 2x squared, take 17x, take 8. So we have 3x squared, take 2x squared, which is x squared, plus 15x, take 17x, is take 2x, and then we have the take 8 that's just sitting there by itself. Okay, so we've done that one, and on to number 12c. Hence, find algebraically the length and breadth of the rectangle. So we have a quadratic equation to solve. X squared take 2x take 8 equals 0, and that's from part B. Factorise that. X, we have minus 4 times plus 2. Minus 4 times plus 2 gives minus 8, and minus 4 add 2 gives minus 2. So that's it all sorted out there. So we have two things multiplying to give 0. So x take 4 could be 0, which would allude to x equaling 4. If x plus 2 equals 0, then x would have to be minus 2. Now that's not a valid solution. X can't be negative. We're talking about the length of a rectangle and triangle here. So x equals 4 is the valid solution here. Now the length of the rectangle is x add 8. Now with x being 4, then that would be 12. The breadth of the rectangle is 2x add 1, 2 4s add 1, 8 add 1 gives 9. So the length is 12, the breadth is 9, and that's the end of the question paper.